All right, so in this video, I'm going to cover 4.6. Okay, so variation of parameters. Uh, the 4.4 and 4.5, we studied the method of undetermined coefficient. Okay, using the method, we could solve the we could find a solution of non-homogeneous differential equation. Okay, so keep in mind is what we are doing in chapter 4. We wanna in chapter 4, we are studying how to solve the second order. Okay, the second order, and then the differential equation. But in chapter 4.1 through 4.6, pretty much we're gonna study how to solve second order coefficient, constant coefficient, and then homogeneous and non-homogeneous. Okay, so cy is equal to f of t, right? So using the method of undetermined coefficient in chapter 4.4, we could find a solution of that, differential equations. And then in 4.5, we study the superposition principle. So using the superposition principle, we could find out the general solution of initial problems, and finally, we could get a particular solution of initial problems. Okay, but mm, we wanna, but there is, the, the drawback in a method of undetermined coefficient. What if f of t is a function which is none of the type introduced in method of undetermined coefficient? For example, f of t is just the natural log function, something like this. Okay, so if f of t is a type that is not introduced in the method of undetermined coefficient, then we cannot solve, right? So we need we need to study more general method. That's the variation of parameters. But always pros and cons. Okay, variation of parameter is 4.6. Okay, variation. Okay, this is the name of the method we're gonna study. So variation parameter. Okay, so yeah, so it is more general method for finding a particular solution. Okay, so yeah, I'm gonna derive this. Okay, and then we're gonna get the formula. Definitely, yeah. So you need to know the formula, and then I'm gonna mention what's the drawback of that method. So think about this one, second order, non-homogeneous, and then the coefficient constant. Okay, so now in here we let y1 t and y2 t be a pair of linear independent solutions. Now it's not a big deal to find out two solutions, right? Be a pair of linear independent, okay, solutions. So what does that mean? Independent, linearly independent. It means that Wronskian is not equal to 0. Okay, key man is Wronskian y1, y2 prime minus y1 prime, y2 is not equal to 0. So for the corresponding homogeneous equation, yep. Corresponding homogeneous, let me say HE, okay, homogeneous equation. Okay, ay dou prime plus by prime plus cy is equal to 0. Okay, I told you it's not a big deal to find out two solutions of the associate homogeneous equation, right? Just find the ox equations and then Okay. So now then what? YH of t. I told you what does that mean? YH. This is the what general solution to the homogeneous differential equation. Okay. This is the general solution. Okay. To the homogeneous differential equation. So this is equal to C1Y1 plus C2Y2, right? So we have done this one. Okay, we saw many examples of this, right? So now next one. Okay, here's a strategy of variation of parameter. So we're gonna replace C1 and C2 by a function of t, V1 of t, V2 of t. Okay, so now here we're gonna replace. Okay, I mean, what are you gonna do? So we're gonna modify the general solution to the homogeneous equation to so that this is gonna be solution of that non-homogeneous differential equation. That's a strategy. Okay, so first step, we're gonna replace C1 and C2 by functions. Okay, so replace C1 and C2, this one by V1 of t and V2 of t. Okay, so now let's say yp then of t is equal to V1 t, y1 t. Keep in mind this, y1 and y2 are known. Okay, y1 and y2 are known, and then v1 and v2 are unknown function. What we need to figure them out. Okay, so now then okay, so p, I told you p doesn't mean the particular solution. Okay, p means a solution. Okay, but yeah, it's just we can say a particular solution, not the particular solution of the to the algebraic problem. No. So we're gonna find out the yp prime. Why we have to find the yp prime? Because to find the v1 and v2, we need to what? I mean, this guy must satisfy this equation, right? It means that when you plug in yp into that differential equation, that equal sign must be satisfied. Okay, so using that condition, we can find the v1 and v2. Okay, we want to find out. It means that we want to find out v1 and v2 such that this guy yp satisfy that equation to be true. So yp prime going to be v1 what v1 prime y1 plus v2 prime y2. Let me skip writing parenthesis and t. Okay, and then v1 excuse me, v1 y1 prime plus v2 y2 prime. All right. So next one is we assume that here assume that what v1 prime y1 plus v2 prime y2 is equal to 0. Okay, keep on this. This is the first one. Now y v1 prime y1 plus v2 prime y2 equals 1. We need that assumption. Yeah, I'll show you later. Okay. So now then yp, then yp prime, this is equal to, now see that v1, oh, can you see that? It's too bright. All right, so v1 prime y1 plus v2 prime y2 equals 0. It means that what? v1 prime y1 and then v2 v2 prime y2. The first the parenthesis gonna be 0, right? So yp prime is equal to what? Just second parenthesis. So v1 y1 prime plus v2 y2 prime. Okay, then yp dot prime is equal to v1 prime y1 prime, right, plus v2 prime y2 prime plus v1 y1 dot prime plus v2 times y2 dot prime. Okay, and then what? And then we're gonna plug in this one. we plug in this one into the non-homogeneous differential equation. Okay, so then let me see. Then AYP dou prime plus BYP prime plus CYP is equal to A times V1 prime Y1 prime plus V2 prime Y2 prime. Okay, why? Yeah, let's do algebra. You see, what? Let me see. Actually, a plus, right? Yeah, that actually, this one is equal to this. Yeah, but I show you. So AP, what is this? AYP dou prime gonna be A times V1 prime Y1 prime plus V2 prime Y, you know, Y2 prime, and then plus what? Let me see. Let me see. Y1 prime. Yeah, then we're gonna get the. I mean, so I'll show you. Okay, plus. Yep, plus. Okay, and the A times V1 Y1 dou prime plus V2 Y2 dou prime. Okay, and then plus B times Y. Let me see that B times what? B times YP prime, which is B times V1 Y1 prime plus V2 times Y2 prime. Okay, then plus C times YP. YP is what? V1 Y1 plus V2 Y2, right? Okay, so you see that A times V1 Y1 dou prime, I mean, this is equal to, okay, I'm going to copy this one, A times V1 prime Y1 prime plus V2 prime Y2 prime, and then plus, and then I'm going to rearrange these three parentheses. Okay, I'm going to rearrange them. All right, so we can say this is equal to A times Y1 dou prime plus B times Y1 prime plus C times Y1 times V1, right? And plus A times Y2 dou prime plus B times Y2 prime plus C times Y2 times B2. We can say that. Okay. Where A Y1 dou prime comes from? Here. A Y1 dou prime. What is V1 right there? Could you see that? This one, and these three terms have common factor V1. Okay, these three terms have common factor V1. So I just factor out V1. There's gonna be leftovers. And then I'm gonna combine these three terms because these three terms have this common factor V2, you see. But you know what? Y1 is a solution. Y1 is a solution of homogeneous differential equation. Y2 is a solution of homogeneous differential equation. So this is equal to 0. This is equal to 0. Okay. So now we got this. This is equal to A, this is equal to A times V1 prime, Y1 prime, plus V2 prime, Y2 prime. That must be equal to F of T, right? So now then we got this V1 prime, Y1 prime, plus V2 prime, Y2 prime is equal to F over A. Okay, now you see in here, back to here, the non-homogeneous differential equation, we assume that A is not equal to 0. Okay, B is not equal to 0, and the C is not equal to 0. Okay, so now we're gonna find the V1, V2 satisfying this one, and remember that assumption, this one. Okay, this is a second condition. So we find V1, V2 that satisfy both that one, this equation and this equation. Okay, so Y1, V1 prime, Y1 plus V2 prime y2 equals 0. And then v1 prime, y1 prime plus v2 prime, y2 prime is equal to f over a. Okay. So we solve this system for y1 and y2, v1 prime and v2 prime. Okay. You see. So keep in mind this. What y1, y2 are known. Okay. All right. So then let me see. From there, v1. Let me see. Okay, v1 prime. Solving this one, we get this v1 prime is equal to minus f times y over y2 over a times y1 y2 prime minus y1 prime y2. Okay, so it's just algebra. Okay, so you say using the substitution method or subtraction method, either just use either one. Okay, then you're gonna get this. Okay, so this is just nothing but algebra. But you know what? This is what actually Wronskian, right? This is Wronskian. And then v2 prime is equal to f times y1 over a times y1 y2 prime minus y1 prime y2. That's also Wronskian. Okay, but we want to find out v1 and v2, not v1 prime, v2 prime. So what? We have to take integral. That's actually the main drawback of this method. Okay, the variation parameter that works for any type of source function, but the problem is that you have to take integral. v1 is equal to integral minus f times y2 over a times Wronskian, okay, and dt. And then v2 is equal to integral f times y1 over a times Wronskian and the dt. Okay, so that's it. That's the variation parameter. Okay, so we're gonna see we see two example. Okay, so and the call it a day. So example. So example 1. All right. So just think about this differential equation. Y dot prime plus 5y prime plus 6y is equal to 18t squared. Yeah, 18t squared, since source function, source function is just due to monomial. Actually, yeah, we can solve this one using the method of undetermined coefficient, but let me solve using the variation parameter. Okay, so step 1 is what? Step 1, we gotta find out y1, y2 which are solutions to the corresponding homogeneous differential equation, right? Okay, so we find y1 and y2, right? Then homogeneous equation is what? Y dot prime plus 5y prime plus 6y equals 0. Okay, then what's the Ox equation? Ox equation is r squared plus 5r plus 6 equals 0. So r is -2 and -3, right? Because r is -2 and -3. So these are simple root. Okay. All right. Since the Ox equation has two distinct real roots, then y1 is what? y1 of t is e to d -2t, and y2 of t is equal to e to d -3t. Okay. Now step 2. Then v1 is what? v1 t is equal to integral, which is negative f times y2 over a times Wronskian, right? Keep in mind this, Wronskian is a function of t. What's the Wronskian? Is y1 y times y2 prime minus y1 prime times y2. That's Wronskian, okay? The dt. Now, this is equal to, what's the function f? 18t squared. So, we're going to get negative 18t squared times y2 is e to the negative 3t over a is what? 1. A is 1. And then Wronskian going to be, let's find the Wronskian, okay? Because we're going to apply Wronskian when you find the V2. So Wronskian is equal to what? Y1, Y2 prime is, second, Y1 e to the negative 2t times Y2 prime is negative 3 times e to negative 3t. The minus y1 prime is negative 2 times e to negative 2t times e to the negative 3t. Okay, so this is equal to negative 3 times e to negative 5t plus 2 times e to negative 5t. So which is equal to negative e to the negative 5t. Okay. Yeah, therefore this is not equal to 0 for any t. Right? This is not equal to 0 for any t. Okay. So anyways, Wronskian is e to negative 5t. So e minus e to the negative 5t. That's in the bottom. Okay, in the dt. All right. So now that is equal to what? Negative, negative cancel them out. Okay, 18 bring it out. So and then t squared, and then we can simplify that fractions, which is the e to the 2t, right? Okay, e to 2t. dt. Okay, all right. So then what? This is the polynomial. This is the exponential function. So two different type of functions are multiplied in the integrand. Then you gotta use the integral part. Okay, so use the integral part twice, then you can get the answer. Okay, I'm not gonna do that because look at the just my lecture note. Okay, it should be there. So you're applying the integral part twice, then you will get the 9 times e to the 2t times t squared minus t plus 1/2 plus c1. Okay, here it is. This is v1. Now, as you can see that we're going to get the one unknown constant integration, right? And then we're going to get the another constant integration in v2. So we have a two unknown constant integration. Okay, so that makes sense, right? Because the second order differential equation general solution has two unknown. Yeah, it makes sense, right? So then v2 of t is equal to what, integral and then f times y1 over a times Wronskian dt, right? Okay. So now where that comes from, f times y1 over a times w. Okay, back then just you know, where's one? Oh yeah. So back to this one, the system of equations of v1 prime, v2 prime. Solving this one, solving that system, we got v1 prime, v2 prime, and then take integral. So we got this. Okay, you mind this? So now, give me a second. So, oh, by the way, I'm sorry. Before going further, yeah, I didn't explain about this. The this one. Why we need to assume this? Because you see that for v1 prime y1 plus v2 prime y2 equals 0. Because what if v1 and v2 are just a linear function? So that derivative of v1 and derivative of v2 are just constant. Then this one becomes constant times C1 y1 plus constant times y2 should be 0. Why? Because y1, see that C1 y1 plus C2 y2 are what? General solution to the homogeneous differential equation. For any constant C1 and C2, that must be solution to the homogeneous differential equation. Okay, that's why we need to assume this. Okay, so now back to the example 1. Okay, so and then we need to find out V2. So V2 is this, F is 18 t squared times Y1 is e to the negative 2t over A is 1, and then run scan is what? Negative e to negative 5t, and then dt. Okay, so that is equal to 18 times integral t squared, and then minus, okay, and then e to the what? Let's see, e to the 3t, right? Okay. Also, you have to apply the integral part twice. Okay. So the uh the the solution, the applying integral part in the should be in the lecture note. Okay, look at that. Okay, so applying integral part twice, you're gonna get this negative 6 times t squared, and the e to the 3t, and the plus 4t, and the e to the 3t, and the minus 4 times 1/3 e to the 3t plus c2. Okay. Let me see. All right. So now what? Keep in mind this. CYP. What? So the question is to find a particular solution, right? I mean a solution. All right. So V1. Yeah. So V1. The So we got this. Y is a finally we got this. YP of t is equal to V1 of t times Y1 of t plus V2 of t, and then Y2 of t, right? So we know Y1 and then Y2, right? This is equal to, V1 is what? V1 was this. V1 is this one, okay? Plus C1. So plus C1 times Y1 and t plus V2 is this one, plus C2. It's some term plus C2 and then Y2, t. We can say that, right? Then we can get this. Y1 of t plus y2 of t functions, okay, times y to t plus c1 y1 plus c2 y2. But we know that c1 y1 plus c2 y2 are just what? General solution to the homogeneous differential equation. That should be 0. It means that we don't need to put c1 and c2 actually. Okay? All right. Does it make sense? Okay. So now the let me see. What? So the particular solution gonna be just the v1 times y1 plus v2 times y2. Here v1 must be just 9 times e to 2t times this one, okay, and then just ignore that, okay, put 0 into c1 or just take it out, and then for v2 is this one plus 0, okay, just ignore that or take it out, okay. And then now give me a second. So then what what about the general solution? How can you find out general solution to the non-homogeneous differential equation using variation of parameters? So example, next one example. The first example was to find out a solution to the non-homogeneous differential equation. In this example, find the general solution. Then we need to apply the superposition principle. Okay, find a general solution to the y dot prime plus y is equal to secant of t. Okay, so step one, what we find out the general solutions to the homogeneous differential equation. Okay, you know what I mean. You remember that? What's the superposition principle? Superposition principle says that the general solution to the integral problem, or we can say general solution to the second order non-homogeneous differential equation must be y is equal to yh plus yp. Okay. So YH is a general solution to the homogeneous differential equation. YP is a particular solution to the non-homogeneous differential equation. Okay, we're gonna find out YP using the method of uh, variation parameter. Okay, so we find out the general solution to the homogeneous differential equation using just yeah there's no name, but okay, just using find the Ox equations and then figure out the number of roots in the Ox equation. Okay, so then the step one, find out YH. Okay, 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 but okay. So now let's see. So YH. All right. So Ox equation gonna be what? R squared plus 1 equals 0, right? So R gonna be plus minus I. Is that? It means that alpha is 0 and beta is 1. Then YH of t is going to be C1 cosine t plus C2 times sine t. Actually, C1 times e to the alpha t, but alpha is 0, so exponential term just gone. Okay, plus C2 times e to the alpha t, but alpha is 0 because alpha is 0, so alpha e exponential term just gone. Sine t. All right, so this is homogeneous differential equation. Now step two, well, we find the yp. Okay, so using the variation parameters. Okay, all right, so the first sub-step is we need to check the linear independence. Okay, but yeah, so I didn't check the linear independence. Okay, but actually you don't have to. Okay, but yeah, I just want to make sure that y1 and y2 are linearly independent. Also, we need to find the Wronskian, right? Okay, so w, the Wronskian gonna be y1 y2 prime minus y1 prime y2. Okay, so this is equal to cosine t times you see that? What's y1? This is y1, right? This is y2. Okay, so derivative y2 is a cosine minus y1 prime is negative sine t times y2 is sine t. So which is what? Cosine square plus sine square, which is 1. So it's not equal to 0. So Wronskian is 1. Oh, it's just really awesome, right? Because then, the integrand gonna be really simple. Has a real simple form. Okay, so Now, the second one, then V1 t is equal to integral, right, minus f times y2 over a times Wronskian dt, right? Okay, so that is equal to the integral. What's f? F is what? Secant, right? Minus secant t times y2 is the what? Y2 is sine t. Sine t, okay? Over a is 1, w Wronskian is 1, dt, right? Okay, so now that is equal to minus integral, and the secant is 1 over cosine. So we got sine t over cosine t dt. Okay, so this is equal to negative integral sine over cosine tangent, right? So tangent t dt. So this is equal to what? What's the integer tangent? Okay. This is the what? The integer of tangent is secant, right? The derivative of secant is tangent, right? So now we got this. This is equal to, I'm sorry, the integer of the tangent is a natural log of secant, right? Okay. So this is equal to minus natural log, okay, secant t, okay, plus c1. Right. But that is equal to, you know what? Actually, secant is what? 1 over cosine, right? So minus natural log absolute value 1 over cosine t plus c1. Okay, but this is equal to minus natural log what? Cosine t to the negative first power plus c1. So that is equal to minus, and then we can put move minus 1 out of the natural log, right? So we're going to get positive the natural log absolute value cosine t plus c1. Okay, so now the 2 and the v2 t is equal to what? Integral f of t and then y1 of t over a times w dt, right? This is equal to what? Integral secant, secant, yeah, secant t, and the y1 is a cosine, right? T over 1 dt. So that is equal to integral and the secant t times cosine t dt. Because what's the secant? Secant is 1 over cosine. So this is equal to integral 1 dt, right? Because secant is 1 over cosine. So this is equal to t plus c2. Okay. Now step then now what? The last one, the particular solution gonna be what? v1 t times y1 t plus v2 t times y2 t. Okay, right? Okay, so now here and then what? 1, 2, 3, and then step 3. Okay, now using the superposition principle, we're gonna add them. Okay, normally, yeah, that's true. But what? When you find when you get the problem asking you to find a particular solution, you just ignore C1 and C2, okay? Because a particular solution should not involve the unknown constants of integration. So we just plug in 0 into C1 and C2, or you can say just ignore C1 and C2. But when you get the problem asking you to find out the general solution like this, find the general solution using the variation of parameter, then you don't have to, don't take the C1 and C2 out, okay? And then you don't have to apply the superposition principle. Why? Because think about this. See, YP here, okay? let's figure out v1 times y1 plus v2 times y2 in detail. Okay, what happened in here when we don't take out c1 and c2? Then we're gonna get v1 is what? v1 is a natural log absolute value of cosine t plus c1 times y1 of t plus, what's it, v2? v2 is a t plus c2 times y2 t, right? This is equal to, we can say natural log absolute cosine t, okay, right? And then y1 of t plus, let me use bracket, okay, plus, and then t times y2 t bracket plus c1 times y1 of t plus c2 times y2 t. We can say that, right? So if we don't take out c1 and c2, then this is exactly same as the what? The yh plus yp. So we don't have to apply the superposition principle. Okay, already applied. All right. So now we can say that the general solution of that problem is what? yh plus yp, which is this actually, which is this. Okay. So you see the bottom one, second term, second bracket is the what? General solution of the homogeneous differential equation. The first one is what? Particular solution to the non-homogeneous differential equation, right? Okay. So actually this is the yp. Okay, and then this is the yh actually. So solution, this is solution. Okay. All right, so let me stop here. Okay. So and then probably I'm gonna give one more example for this one, maybe or may not be. But please look at the example in your textbook. Okay, and all right, so for this one, and then I'm going to continue to cover the 4.7.